So, my name is Jeff Mitchell. I work on a project from HashiCorp called Vault, which is secret management software. And I'm going to talk about, the title is Think Like a Vault Developer, Securityduction containers. And this is somewhat of a talk about understanding basic tenets of security as someone that works on a security product thinks about things, and exploring properties necessary for secret management and distribution. I know eyes are going to be glazing over immediately and already. I promise this will be more interesting than you think it is from that slide. And hopefully it'll be something that you'll learn a lot. Okay, so goals for this talk. So this is applied security. This is Securityduction, response traffic orchestration, things like that. It's something that will elevate your risk if exposed to unauthorized entities. So these are things like database passwords, right? So if exposed to unauthorized entities, you can get into your database, they can do bad things. Unintended consequences are harm, so these are things like regulatory fines if someone leaks documents that say you're doing bad things. Identity spoofing, getting credit card numbers and having data breaches, things like that. Those are harms to your organization. It can even be something as simple as some kind of embarrassing revelation coming out that causes eventual loss of customers. All right, so getting it kind of full circle. So an exposed secret elevates risk. It may cause harm, so an exposed secret is a threat. Right? So that's kind of the sort of high level, when we say secret, what do we mean? We mean something that causes, that is a threat to your business because it can cause these unintended harm and it can have consequences and is risky. Okay, not everything that can be exposed is a secret. There are identifiers, things like your GitHub username versus your GitHub password. One's an identifier, one's a secret. And generally, when we're talking about identifiers, they're things that we might want to protect, but it's not something that if it gets out is going to be catastrophic to your organization. So trust. Trust is something, a trusted entity is something that will not divulge the secrets that it has access to. So your lawyer is probably someone that you trust because they are, the whole point of that confidential relationship between you and your lawyer is that they won't divulge things that you tell them, even if it's bad things, right? So, so when we model trusted entities, it's companion to modeling threats. If we're saying okay, what is the threat? What are secrets that can get out? What are ways that we can have threats come to our business, elevate our risk? We have to model the trusted entities, the things we can actually trust with the secrets, and that becomes very important. So two concepts here. One is the circle of trust. These are entities we trust with any secret. So for this talk, things like your CPU and your RAM, right? I'm not going to go and say don't trust your RAM, don't trust your CPU. Root users, if someone gets root, it's usually very, very bad on your system. So we're just going to go ahead and say, focus your energies on making sure that people don't get root, and we're going to trust root because you can't really do anything about it. Maybe the cloud, maybe you trust AWS, maybe you don't, but the cloud maybe. A secret management tool, that's kind of the point if you're using secret management tools, is that you can trust it, so that's part of the circle of trust. Things that are not in our circle of trust, your mother's notepad.txt where she stores all of her passwords, that's not a trusted entity. The NSA is not someone that we generally trust, even though they have access to all of our secrets anyways. Random users, etc. Right? So these are things that are outside your circle of trust. The only allowed long-term storage is in your circle of trust. If you have a secret and you want to store it somewhere, it's got to be something that's in your circle of trust. So when you're modeling and you're saying okay, who do we trust? Where are these exposure points where we have elevated risk, etc. Then the only place you can safely store secrets is anything that's in that circle of trust. Okay, chain of trust. And if you've heard of things with secrets in the government, like a chain of custody, someone has to sign off at any point along the way and say, I've seen that this is through and it's open, etc. That's basically the same concept, a chain of trust. So, in our case, it's usually going to be network hops, right, or services that any particular secret travels through from source entity A and source entity B, and where the source and destinations are in our circle of trust. So basically, persistent storage from some location that we trust, and a persistent storage in another location, or RAM, right? So it might be, we have a secret that's on disk and it's encrypted, and we want to get it into RAM inside our container, and how do we do that? That's the chain of trust you have to go through. Any link in that chain of trust is a potential interception point, right? So This can be things like accidental logging, exploitation by a hacker, etc. My favorite is the employee post-it note. You have a secret, it's a password, and people just write it down. And there are lots of reasons that we do that. Okay, so we're going to establish a problem space based on all this stuff that I just dumped into your head, which is managing secrets in a given environment, including containers, means establishing trust chains in the environment. So when we have an application running in a container, how do we get it from wherever we trust it into that container in a secure fashion? And we want to minimize the risk we want to minimize the number of links, because each link is a potential place where that can get intercepted. And we want to minimize the risk per link. So is there anything we can do that says, okay, even if it's in transit on the network between point A and point B, what are things we can do? Or if we have to put it somewhere where it can't be encrypted, like we don't have a key yet to decrypt it, like what can we do to protect that? Okay, so in other words, figuring out how to securely get a secret from producer to consumer, right? Like, duh, right? Okay, we can all agree this is obvious. You already probably all knew that when you walked in here. It's like, okay, what do we have to do here? But you have to take the roundabout approach thinking about this, because trust levels and trust chains are very important. You have to be able to model stuff. Only after you understand what you can trust in your environment can you actually figure out how to model your data flows and how you can use orchestrators and you can use all these other things to do things in a secure fashion. You can't get there just by saying, well, I think that we can trust this. Like I think that we can do X. Like you have to figure this stuff out, and doing that requires knowing what your trusted entities are, and knowing what it is that you need to protect in the first place. Right? Like what's a secret for you and your organization? Because what's a secret in any given organization might be different from others. Right? Things that are potentially sensitive if they get out, or secret if they get out, or can cause harm if they get out from we're in Microsoft right now, might be very different from like Joe's tractor importing. Okay, risk cannot be fully mitigated. We just have to remember that, and we have to just assume that any given secret can eventually be divulged given enough time. So, and the ultimate goal is zero trust, which is basically like, don't give the opportunity for risks to come in the first place, right? If you have a zero trust model, it means you assume that there really is, ideally there's nothing in that circle of trust and everything's ephemeral. You can't really get there, but you can basically strive towards that goal. Okay, so here's something I'll go back to a bit. So, so if we have a goal, we have, let's say, a scheduler agent. If you're running containers at scale, you have a scheduler. I don't think that's going to be a statement that anyone here disagrees with, is my guess. But if you're running enough containers, you got to have a scheduler to deal with them, or an orchestrator. So if we have a goal, securely move secret from originator to new containers rank. Well, what does that look like? Does it look like that? Does it look like this? Does it look like that? Right? So, what can we do? Okay. Well, to figure out how we do this, first, let's define some security properties and success criteria. So what does it mean if we do this in a secure fashion? If we get secrets from outside a container into a container, what does it even mean? What are the success criteria there? Okay. So establishing a chain of trust requires defining the requirements that must be fulfilled to keep that protected. And the good news is we often need to do this only for one secret. And the first secret authenticates us to top door. So if you're using something like Vault, if you can get a Vault token to your container, you can use that Vault token to get access to all sorts of other things. Same with other secret management systems. Or even something like if you're using AWS, and you're using ECS or something, and you get an instance profile that gives you access to KMS, that's the same concept. Right? So this is the secure introduction concept. Right? So secure introduction is basically getting that first initial secret that allows you to then be authenticated and be secure to get other things. And this is it's a pretty hard problem. We think about it a lot. It's hard because sometimes you don't actually have protection. If you don't have a TLS certificate yet for your client, how do you get something there in a protected fashion? Right? This is not a trivial thing. Okay, so I mentioned success criteria. So the first thing is establish success criteria based on your organization's acceptable risk. Any given organization needs a security policy. It's not going to be the same as anyone else's, although it can be informed by other people's. But within any organization, if you want to do things securely, you have to figure out what that means, what the success criteria And the reasons that you might not need to establish a security policy are absolutely none. Right? Like, you got to do this. And kind of as an anecdote here, I had someone from a very large retailer come up to me and say, hey, we want to use Vault, but we're really worried about Vault does this thing where it shards the master key for Vault into key shares, and you have to have multiple people actually combine into the main key. And so that prevents any one person from being able to like unlock Vault and do bad things with it and replace the binary or do something like that. So they were saying we're really worried about our unsealed key management because we're a retailer, and if we have a problem over Black Friday or something, let's say, or the holidays, then we can't unseal a new node, we can't get secrets, we could lose hundreds of millions of dollars of revenue. I said, okay, but you have to trade off an increased risk if you're doing things in a secure fashion and you're sort of trusting entities, you're sort of going all in on this and modeling your security policy. Part of modeling a security policy, modeling your risks is, what about the increased risk of a breach or attack and the financial consequences from that, right? So, I did some research this morning. So like systems can be recovered. If you have a learning setup, if you have like, some kind of other systems ready to take over from a backup, whatever, systems you can recover from quickly. But if you lose data, that has a very, very long tail, right? So I did some research like TJX, the TJX group, the credit card hacks, 256 million is the losses there. Best Buy, 100 million to 256 million. Home Depot, 236 million, Target, 252 million. These are data breaches, right? So yeah, you could lose revenue if something goes down and things are inaccessible and you're because of the security baked into your systems. But like I said, there's a long tail of data breaches causing very, very bad things over time. And usually you'll see stories where it's like, okay, we think it's going to cost 100 million now, and then like over 4 years, it actually costs us 300 million. But maybe for the retailer that risk is acceptable, and that's why security policy for them is not necessarily the same as for every other person. So success criteria. So this is what is required to security properties are required to implement the security policy for your work. So for this top, don't let them live forever. Don't let secrets live forever. And really by secrets I mean the first secret, because this is talking about security protection. Don't let them live forever, so they need to be rotated or expire. Distribute them securely. Have a break class procedure. Limit exposure if disclosed. Detect unauthorized access. All right, rotation expiration. So I mentioned as lifetime increases, you should basically assume that any secret will be divulged. If it's sitting around on a system forever, just assume that it's going to get out there in some way. Now, if it's encrypted, if it's an encrypted blob, maybe that's okay as long as the key hasn't also been sitting around somewhere. But basically, you should just kind of assume that over time, secrets need to be rotated because if someone gains access to data, and let's say that it's RC4 data, like that can be cracked pretty easily now, right? So you never know what's going to happen in the future. There might be huge major advances on the AES, and suddenly AES 256 is out the window. Caches logs, debugging. If you have secrets written to debugging, or you have sensitive values written to debug logs, like, are those logs going to go away at some point? Maybe, maybe not. Maybe they'll sit in your log system forever. So secrets should be rotated frequently, and this really depends on exactly what it is and how easy it is to rotate. If you're rotating TLS certificates in Nginx, it's a simple hop. If you're rotating TLS certificates in your random custom software that's in some, that's in like Fortran, that might not be so easy, right? That might require taking system down, putting it back up. So it should be rotated frequently based on your needs and what makes sense for you. But I want to kind of point out, user passwords versus machine secrets. So who here, raise your hand, who here knows what those 4 words are? Okay, a bunch of people. And out of those people that are raising their hand, how many of you have actually looked at that XKCD in the last couple of years? Okay, so okay. I was going to see if anyone said, no, I just remembered it a couple years later because it made an impression. But for those that don't know, XKCD is this webcomic, and it had this thing that was talking about how we've trained people over time to basically use passwords that are easy for humans to forget, so they're more likely to write down, but really easy for machines to guess. Because it's usually variations of a dictionary word that just like substitute an O for a 0 and things like that. I think what he used there was troubadour, and it's just like, you know, the A was an at, the O was a 0 or something, and it's really easy on the computer to just go through a dictionary and make the substitutions. You know, for user passwords, like less frequently and more used, more likely to be seen, but for machines, it's just data, right? Machines don't really care. You can make that password with machines using 50 characters that are purely random. It doesn't care. It's just a string, right? So machines can rotate much more easily, and they can use, you know, better passwords. They don't need to rely on like human memory. So that's really kind of, you know, the point there being rotate more often and make those passwords strong and make them random, because machines don't care. Right? Whereas if you're rotating your own, actually my wife's company, she has to rotate her password like every 3 months. And rather than actually try what it, you know, to remember what it is, she basically like appends a number every time that increments. And their policy that they don't catch that. And it's a good password, but not that I know it. Yeah, I don't know it. Anyone who knows? No, I don't know that password at all. I've never had to log on to her company computer. I'm gonna stop talking now. Okay, so distribution. So the literal movement along the chain of trust. So to, from, people, machines. And base level should never be plain text, always covered. Covered doesn't mean encryption necessarily, because if it's encrypted, you need a key. And I'm going to talk about what we've done with Vault to help with covering. It's something we call response wrapping. But basically, you know, you may have to kind of look at what you're doing and figure out, like, okay, if we have entities that we trust, maybe we trust KMS for running on ECS or something, or maybe we trust like some kind of secret store. You know, if you're running on Kubernetes or some kind of secret stuff, like maybe we trust that. So, you know, how can we get something from there and like, you know, ease detection, let's say, rather than necessarily make it something that where you can't securely introduce because everything that you want to decrypt means something in the first place, right? And this is why I'm talking about secure introduction, because once you have that, everything else becomes much easier. But it's a tough problem. Okay, so limit exposure. So principle of least privileges, right? Logging credentials, you should not give root access. You should give very limited sudo necessary. You know, these are obvious things. API credentials should have a minimum function set. DB credentials should be limited to tables operations and things like that. Access detection. So things have a way of being leaky. So let's, you know, envars. If you go on Docker Hub and you look at like, okay, Postgres, like, oh yeah, pass your Postgres password in through an envar. This is a bad idea, right? Envars get leaked everywhere. They, you know, a Docker inspect. You know, a lot of orchestrators will just like log the jobs that you want, like, you know, to log in for debug, right? Makes sense. And you don't even need Docker commands orchestrators to like see envars for processes. You know, if someone has access on a system, appropriate access, they can just do that. So, you know, envars are a common way, but they have all these problems. So you don't know, you know, one of the worst things is you don't know if that secret is actually been accessed by the wrong party. Right? You don't know if someone looked up your envars or saw them in the debug log, or how many people saw them in the debug log. And if someone then uses that password, you don't know who did it. You know, so equally as important as protecting is knowing if an unintended party has intercepted it. For the reason I just explained. Audit logs are great. How many people look at audit logs regularly? Okay, one person's sort of waving their hand. It's funny, so the last time that I gave this talk at HashiConf, I had like a few people raise their hands. But at one previous time, I gave a similar talk and I asked the same question. And one person raised their hand like right off the bat. I was like, oh, I do. And I said, you look at through like every single log and every single thing that happens? And he said, yeah. And I was thinking, man, you are amazing. You know, I would never do that. Nobody has time. So active detection is better. You know, can you go through our logs? Can you log enough information you can actually figure out who's using what when, and find out patterns, things like that. Okay. And finally, break glass procedures. So, are you compromised? Now what? Turns out you actually have to figure this out during the planning process and during, when you're writing your security policy. You can't wait until there's a breach and then try to figure out what to do, because you're not going to have the logs that you need to actually figure out what's gone on and who's used what and where people have logged in and all these kinds of things. So you have to figure this out ahead of time, what your break glass procedure is. So it might be things like stop all further access, rotate all secrets after establishing the identity of legitimate secret holders, things like that. Good news, everyone. You don't have to face this problem. So all these things that I just told you about, like all these things you have to consider, and the whole like secret introduction problem, you don't have to face this alone. There's been an explosion of open source. There are some proprietary ones as well, but there's been an explosion of open source secret management tools, things like Keyless and Ops and Conjure, and this little thing I like to call Vault, that maybe you've heard of, and I have to put in rainbow colors because I recommend it. But I'm biased. So if you only take away 2 things from this talk, then here's what you need to take away. One is write your own crypto, the other is using a secret management tool. No, okay, right? Right? Like just, maybe some of you were like, what did you say? No, it's, use a secret management tool. They're out there, they do good work. Don't roll your own. It's tough. You wouldn't ask me to develop like a Java enterprise, a Java EE app, because I don't know how to do that. Don't write your own secret management tool. There are more out there than there ought to be perfectly honest. Although a lot of them are actually just like wrappers around KMS, where it's like we just want to do a better API around KMS, and that's all well and good as long as you're only ever going to use AWS. So Docker, at a ContainerDays conference, there's less people using ECS versus other things, but like, a lot of people use EC2 still, and it's like, oh, well, we could move on to other things that might be cheaper if only we weren't using all of these proprietary Amazon services. Getting off that train of thought, use secret management tool to double your own. It's really difficult, honestly. Help improve what's out there. Okay. So one kind of quick caveat is I'm going to talk about things that like secret management tools can do for you. And what I really mean here are things that if you're using Vault can do for you, and other secret management tools may or may not have those capabilities. And there are things that other secret management tools do that Vault doesn't. There are things that Vault does that other secret management tools don't. But really this talk is much more about, it's not intended to be like a tool talk, but it's more about like understanding the paradigms, understanding the things you have to think about when you're thinking about getting like that first secret into a container. And just Vault has a focus on providing security primitives as opposed to like being an API wrapper. So we can create some pretty complex workflows which are nice, and you'll see how this provides flexibility for this problem. So secret management tools, they're centralized. They help avoid secret sprawl. So sprawl is things like secrets everywhere with different access control lifetimes, coverage. They might be easy to forget, misplace. Were you at some point checking secrets to Git, and now like have all those copies of that Git repository been deleted? Did they live over on this team's like private 1Password and this other team's private 1Password? Like secret sprawl is not a good thing. It's kind of the same. There's a lot of sort of with the microservices stuff. There's a lot of narrative of like centralized things are bad, right? But banks are centralized, and there's a reason that people, without getting into the politics of like should you trust banks and their behavior and like whether they're corrupt and all that, but there's a reason that you trust banks with like money, right? It's because they provide a central kind of secure way to like you put your money in and it's FDIC insured and it does all these other things and you can earn interest on it and you can do whatever you want, right? But the point is like people go to banks because it's safer than keeping money under your mattress, probably. So centralized doesn't necessarily mean bad. And it helps avoid sprawl, which actually is a real problem that people have. Centralized management. It's really nice to be able to say, I can go to one place and find out who has access to what secrets and where, right? That's great. Auditing. So being able to then find out who actually accessed these things. So these are things that you can do with a centralized tool that you can't do by just kind of ad hoc. Codified secure access mechanisms. You want TLS 1.2, but instead of TLS 1.0 between every communication that goes up that like carries your secrets. Great. You can configure that in one place and say, my secret management tool only accepts TLS 1.2, right? This is something you can do, and that's a good thing to as well. So that's another kind of advantage like centralized. And they can also do things like secure rotation, replication, expiration, depending on capabilities of the given tool. So, a lot of secret management tools have a very explicit focus on secure introduction problem, by getting that first secret to you, because they know that you have to actually have that first secret before you do anything else. So core competency like necessary primitives being built in. You can support existing secure introduction paradigms like LDAP or something, or Kerberos key tabs with 100,000 containers, but do you want to manage that? Does that scale at a high rate? Do you want to generate 100,000 Kerberos key tabs and drop them? And if you can drop them in the right place, you've solved the secure introduction problem anyways, and you don't need any of this, right? So it's not that secret management tools make the problem go away, they just provide tools to implement the solution. Okay. And I think I don't know when I can go until, because it kind of started at this weird time, but I'm going to, hope I'm not going too long. So anyone working with tasks I mentioned is probably using a scheduler. Schedulers are sources of truth, right? They know what's going on in your containers. And they provide hooks, right? They have plugin systems, or they have like integration points that you can submit a PR against or whatever. So they can be a magical combination if you can combine a secret management tool and a scheduler. So going back to this example that I had before, the scheduler and the agent are more like traditional applications. I'm going to be very like hand wavy about authenticating those. Right, so I'm just going to say like, all right, so like let's say you're using Vault, maybe use Vault alias EC2, and you're running Docker, or you're running whatever you want to run, a Swarm or Mesos or whatever on EC2. And I'm just going to kind of assume that the scheduler agent can get a token. And I'm hand waving because we're talking about containers here, right? So like let's keep the focus there. So here's the new part. It's like, okay, but now I have containers, so maybe for EC2, maybe I could use like Vault. There's a way to use its instance metadata profile to authenticate. So all right, but I can't do that with the container, right? So what can I do? Okay, so this is where I get a little bit more into like specifically Vault, but like here's why it's important. So a Vault token has limited or unlimited use count. So a token is like a session cookie for Vault, right? You are given a token, you can use it to do stuff. It's like a ticket granting ticket. Limited time to live, maybe renewable, but maybe not. Set of authorization policies. You can say like, all right, I have an authorization policy that lets me hit up these aspects of Vault and like do these things within Vault, and only these things. So for instance, you use that first token to get application tokens. A consistent ID and audit logs. You can track what a particular Vault token did the whole time. And it has something that's really important, which is it has token scoped secure storage. So I can use a token, and I can write a value into this thing called the tokens cubbyhole. And that is something that no other token within Vault can do. Only that one token. Only if you know that token ID, you have that session cookie, can you actually read and write that space. So my claim is that these primitives allow excellent secret coverage when you want to like get a secret from point A to point B. So I'm going to walk through like an example workflow here. So we have a scheduler, and the scheduler says, all right, here's a new job, and the app is, the job is a DB writer. And the security policy attached to it is appdb rewrite policy. This scheduler agent says, okay, so the scheduler agent has unlimited uses, and it has renewable TTL, so it can like keep going as long as it wants. And it has a policy that says I'm allowed to create app tokens. So it goes to Vault and says, I'm going to use my policy to create app tokens, and the policy that I want is an app token that has appdb rw pol attached. And Vault can come back and say, okay, so I'm going to use this cubbyhole thing, so I'm going to give you back a token, and inside that token's cubbyhole, where only this one token that I just gave you can read it, is another token. So on the inside, we have an unlimited use token with 1 hour that's renewable. So you can use this token to get DB creds every hour. You can use it to get as long as you want, but like you can keep using this token as long as you renew it, and as many times as you want. It has the appropriate policy that is required to get these database credentials. And I'm going to put it inside, and put that token value inside this returned single-use 30-second long token that only has the ability to read its own cubbyhole. So basically, it's being wrapped, right? So you have an inner token, that's your actual thing. You have this outer token that all you get back is just an opaque token identifier. It can only ever be used one time, and only that one token identifier can be used to actually read the token that's contained inside. Okay, so now the scheduler can start the job, start the container, and say, I'm going to put this, here's a token, it's this thing. And we'll see that, in fact, when you do something like this, you actually put it inside your environment variables. And that thing that I told you not to do, you can actually do it, and I'll explain why. So then the container can go to Vault and say, like, all right, I want to read it out of the cubby hole. I'm going to like give me this thing that's contained inside, and it gets it back. And then from there on, you're off to the races. I want to go get DB credits, like use this policy that I got. I'm going to get application database credentials. I can use that over and over. Here's your user. Here's your password. It expires in 24 hours, and maybe other things if it has other policies. You can get TLS certs, whatever. Okay, so yes, yeah.
Can you just repeat the key that's the cover encryption? You said it lasted for 30 seconds or whatever, but what is it?
Okay, so the idea here is that within Vault, there's two tokens, right? So the first token is a thing that you're actually going to give to the application.
Right.
And the value, so it's like a 128-bit cryptographically secure randomly generated number, right? And that value is basically stored inside a second generated token's private secure storage. And that outer generated token that has that where put inside that secure storage has a single use and has a limited lifetime.
And you're sending it?
Yeah, and so
Clear.
yeah, you're sending it in the clear. Now you don't necessarily have to send it in the clear, but part of the problem that I've been describing is like that first thing. If you're not sending it in the clear, how do you trust it in the database, right?
But the point is, this could be intercepted, right?
I'm going to get to that. Have faith. All right. Okay. So how do we do? And detect unauthorized access is the last bullet point for a reason, because I go into that more detail. So don't let them live forever. So the outer token that's wrapping the inner one expires. It has a single use limit. And the only copy of that inner token that we want to give to our container is inside. Distribute them securely. So the inner token is covered the entire way. The inner token's value does not go across the wire. It doesn't go into environment variable. Limit exposure to disclose. So only specific access policies are granted, like get database credentials. That's kind of an easy one. Break glass procedures. So we can at any point we can like lock down Vault. We can lock down the secret management tool. You can use audit logs to ensure that you know like what was generated when and was that ever used and what was used to do. So there are audit logs. And so now detect unauthorized access. So here's what we do. We say, all right, because we have this time limit and this use limit, we can actually detect whether the wrong person intercepted. So the application running the container says, I'm going to read this inner token. If I get this value back, great, everything's good. If it reads storage and no inner token is found, that I've never seen that happen, but like I guess in theory if there's some really bad error, then log it. But let's fail a job trying to enter something. But invalid token. So when you wrap it, you get back the current time, the TTL of the token, and the token value. And we can check the current time and say, okay, did this expire? Is it past the expected lifetime of the token when I'm trying to unwrap it? And we say, all right, well, if so, something along the way, like your application can say, all right, why did I take so long to start up? I should maybe raise like a yellow alert. This is basically like, I took too long to start up or it took too long to get this token into me. And so there's a problem here. We should figure it out because this is bad. And we should also make sure that that token that was generated for me goes through the audit logs and make sure it was never used. But if it's not expired, this is a big red flag. Raise a big red security alert because it means that someone else read that value out, right? Because it's a single-use token. So if you can't unwrap it and you're within its lifetime, then either someone actually revoked that token out from under you, like revoked the wrapping token for some reason, in which case, go through the auto logs and figure out if that happened, or it means someone else actually used it, in which case, go through the auto logs and figure out what happened. Right, that's a break classifier. So because of the fact that there's that single use, then we can know whether or not the wrong person ever intercepted a value. And sometimes that's the best thing that you can do. Sometimes that's the best thing that you can do, right? It's not like when you're talking about the secure introduction problem, you can't get, unless you can pre-share keys ahead of time, in which case, how do you do that? Is that secure, et cetera? But maybe you can pre-share keys ahead of time. You like SSH into that container if you really want an SSH data running inside there, and you like drop something in the container's RAM disk or something. You can do things like that. But usually you don't really have like trying to figure out paradigms like that are just kind of lead you in a bad path anyways. So sometimes the best thing that you can do is make sure that it's never exposed in plain text, and make sure that you know whether or not the wrong person presented it. So like within Vault, we actually, like this becomes such a useful thing. We initially did it for exactly this. Like when I started working on this problem, I'd actually come from Akamai. I was helping them get one of their departments get to like a containerized model, and was working through like, okay, how do we actually get something securely into a container? And then I joined HashiCorp and built this in Vault. And it turns out it's so useful that you can actually within Vault like do this pretty much anywhere. You can actually get pretty much any response wrapped. So if you want to generate TLS certificates on behalf of somebody else, but you never want to have the private key for that TLS exposed to anyone but the end application, you can just get that wrapped. You can wrap pretty much anything Vault can do. But one thing to point out is, the mechanism is not container authentication specific. Like you can, wrap a value and inject it into a shroot. You can do it on EC2 instance, whatever. So that's a little bit of a slight bit of a Vault plug, but mainly just to point out that this kind of paradigm that I'm talking about is useful for Securityduction, but it actually ends up being useful everywhere if you have this kind of capability. And a nice thing about this is like if you integrate it with an orchestrator or a scheduling agent, I mentioned it can be a really magical combination because other things you can do is if what's coming back from Vault is a token, if what's wrapped inside is an actual token, then we have this thing called an accessor, which is basically a reference to the token that doesn't divulge token properties, but lets you look up properties or doesn't divulge token ID, but lets you look up properties and lets you revoke it. And so the scheduling agent can actually just store that value and say, okay, as soon as this job terminates, I'm actually going to just use that and revoke the token that's given there, even if there's 6 hours left on lifetime. Because why should you let it live longer than it needs to, right? So I'm going to talk real quick just about how we integrate this in Nomad. I think I mentioned later. Yeah, so I'm going to talk a little bit about Nomad, but this is actually, there are other things that have gone on with other schedulers as well. But with Nomad, we actually have a variation on this. And what happens is a user comes and submits a job. And they provide, I actually forget, because I didn't do this integration, but I forget if they provide their accessor or their Vault token. But basically, they provide to the Nomad server the job request. And they say, here's my token or my accessor. And I want the following policies for my application that's started by these jobs. And what happens is it can actually go and say, all right, I'm going to verify that the policies you're requesting are policies your token has access to in the first place. And if so, great. I'll create tokens for you on the fly. Like whenever an instance of this container is started up, it'll get a token created for it that has these policies. And if not, sorry, this job is rejected. So we actually do like checking in the Nomad to say, so that way, rather than basically have a user come and say, like, I want to be able to talk to this database and that database, we actually, the user has to be authenticated first before they can submit a job. So you can't do privilege escalation, basically. And the other thing is like the agent, and this is often very useful, is like if you trust RAM and you can bind mount into a container, which you can create a RAM disk, and you can just bind mount parts of a RAM disk into a container, use file system permissions, things like that. So the Nomad agent can actually embeds this thing called console template, but basically it can do all sorts of things within Vault using a token for you, and then just embed the results into a RAM disk. And if you don't know HashiCorp tools very well, like we follow the Unix philosophy, we're pretty agnostic, even though we have tools that compete sometimes with other things in the spaces. Like we tend to be very agnostic to technology. We like to have each tool kind of do one thing, do it well, and not require like all in one sorts of things. And as a result, any scheduler can, everything is in the public API. Any scheduler can do this. Kubernetes, you probably know the name Kelsey Hightower. He's working on doing this kind of integration into Kubernetes. There's a project called Vault Gatekeeper Mesos, which does this kind of thing for Mesos. So even though I've been talking about like Nomad a bit as an example, like there are other things that exist for other schedulers. And I really do, I'm very consistent on this point. I really do believe that when you're talking about getting like secure introduction to containers, getting secrets in containers, that your best bet is to use a secret management tool that integrates with your scheduler. I don't think that it really gets better than that because your scheduler is the source of truth.
What's the name of the last project?
Yeah, it's highlighted. It's Vault-Gatekeeper-Mesos. If you search for Vault Mesos, it's one of the top 2 hits. And the other one is called Vault TCOS, but it's really that's basically just a recipe to get Vault running on TCOS.
Excuse me.
Yeah.
You're saying that as far as Kubernetes, that to externalize secrets into Vault, or is this all
So I think that's, right now it's basically getting a vault token into a container so that you can authenticate a container so that it can then get other secrets. I think that, so I've talked to Kelsey quite a bit, and I've talked to him about what he's doing here. And I think that he would like to get Vault as kind of the official sort of adopted thing that Kubernetes uses, mainly because it just does all the stuff already. Like rather than build a secret management tool into Kubernetes, it's like, why not just have an API that does Vault under the hood and they can run it for you, right? So I think he's interested in doing that. I don't know if that's where that's going to go, but right now it's basically doing what Nomad's doing. It's like if you already have Vault, then get a token into a container using a secure workload, using what Kubernetes knows about the state of your environment, and using that as a source of data.
Would that also extend to like your API call?
Yeah, I don't know.
Okay.
So the project I linked to, he's doing it all like on a GitHub repository. It's all open source, so you can feel free to check it out. I asked if he had any issue because it's early with me looking to him. He said no. So I think he's more than happy to talk to people about it, get feedback, and so on.
Thanks.
Yeah. And okay, so yeah.
So we currently don't have a secret management tool, but we do use Kubernetes, and
Yeah.
we know that secrets in Kubernetes don't do like anywhere as much as what you've described here.
Yeah.
Can you kind of describe in a few words like what you're missing out, like what you're compromising on if you just stick with using Kubernetes?
I can't because I don't know, because I don't use Kubernetes myself.
I need to
actually,
learn that first and then come back to you.
there are people that, I mean, I'm kind of steeped in Vault all the time, and so, you know, I'm interested in integrations, but like on the Kubernetes side, that's being driven by people that are in the Kubernetes community. And so I don't really know enough about how Kubernetes does secret management to talk really about that.
It's a lot more primitive.
I do know it's more primitive, and that's why I know that Kelsey's interested in just adopting Vault. Because
The short version is it sticks your secrets in entity in context.
I thought that it was using NAFL, putting it in NAFL box or something.
I don't believe so.
Oh, really?
At least from reading that
Okay.
issues.
Well, that's not good. Anyway, so to wrap up, don't ignore risk, minimize it, right? So Securityduction is a thing. It's a hard thing, but once you solve that problem, you can use that to get other secrets, which is the nice thing about it. It's really just focus on that one problem. Figure out where your risk is. Figure out what your appropriate level of risk is. And remember that security is risk management, right? It's about making sure that you're keeping that minimized and that you understand what the threats are. And you have to model that. So figure out your circles of trust, figure out your chains of trust, et cetera, and then figure out, okay, how are you going to get things from point A to point B? Use Vault or some other secret management tool. There are other secret management tools that will meet your needs, I'm sure. Obviously, I'm personal with Vault, but, and one thing to keep in mind is like a lot of people have mixed and kind of hybrid environments where they have both containers and other things, and the integrations for secret management tools, like there's things like Ansible Vault, right, which is basically like an encrypted data file, but there's also integrations with Ansible and Puppet and so on to the various secret management tools that are out there. So, you know, you can actually adopt a secret management tool, not just for your containers, but also plumb it through, like if you have a hybrid scenario, you can plumb through everything, right? And finally, you know, orchestration tools are great facilitators of secure introduction. You know, when you're trying to figure out how do you do this securely, look at both a secret management tool and whatever orchestrator you're using for, and look for an integration point. In some cases, that ends up being community driven, but it's, you know, but they're there. So, thanks.